Someone wanted to know if I could make the sensor a little bit shorter, and I thought, well, why not? It is possible. As I found out, there's not much to these magnetic sensors. And this is the result, what you see here, and I'll describe it. This is now my probe. As you can see, it holds up quite well. I don't know if you can see the ball underneath there as it moves around. That stays right on target. The original sensor, and I'll go ahead and just drop the ball from that, attach it on the end of here. The original sensor was a little bit longer. In the other video you can see just how long it was. Let me go this way. This camera, I have to apologize for the camera here. It's just iPad camera is not that great. Sensor was about that long, and essentially this black portion right here, this is the business end of the original of the Vernier magnetic sensor. There's a little pin here you just knock out, and this comes right off because the sensor was able to pivot 90 degrees, and so it come right off, and it gives you access to the wire, a 3-lead wire that's on the inside, and it goes to a little chip right at the end of this sensor here. You just pull the chip out, unsolder the 3 leads, and splice in a new wire. As you see here, this is not the original wire. That's the wire that I've put in. It's just a flexible wire that I've had sitting around here. You can get a much better wire, and I may still do this, from like Radio Shack, one that just has 3 small leads and extremely flexible. This is still good enough for what I need. But anyway, what I have here, this is the original part of the Vernier sensor with the magnetic, or the chip in the end. This here is just a 1/2-inch wood dowel, and it's solid. I didn't have to drill a hole through it or anything. And then the 1/2-inch magnet here, the refrigerator magnet. Of course, this is the rare earth magnet there. The reason for the dowel is there's one reason for it, and that is the fact that the sensor is here, the magnetic sensor is here, and when these two magnets are combined, they put off a pretty strong magnetic force. If they're too close to the chip, the sensor chip itself, it'll actually exceed the sensitivity of this chip. So what you do is you create space. There has to be enough space in here so the sensor doesn't go beyond its max range. That's only about, I made that about 15 millimeters long, so just about 5/8 inch long. You could actually make that as long as you want to a certain extent. At some point, the magnetic field won't be strong enough for the chip to pick up. So anywhere from 5/8 to 1 inch long, and you can make this out of anything. Plastic, you can't make it out of metal because that'll magnetize unless it's aluminum, but this can be solid wood, plastic, just anything you want it to be other than something that's magnetic. So anyway, that is now the sensor, and it's a whole lot easier. Basically a mini probe. If you're familiar with the Magic probe, they have a little version of it, and you still have this to deal with, as you can see, this menagerie of wire and the original part of the sensor here. You can just put that off to the side, plug it into your computer, and so a lot of wires, so it is a little cumbersome as far as the wires go, but there's a pretty strong magnetic force there, and it's definitely strong enough to keep this guy nice and level, and you don't have the height that's going to tip this thing over. So it's really light, easy to use, and you can see it there, just kind of, and this will also go over, it's strong enough, it's going to go right over the tone bars. In the next video, or I'll just splice this video together if I have a chance, but I'll show you how to calibrate this through the software, which is extremely simple, but I know people like to see things. I had a couple questions on how I calibrate this, but because it actually does read in thousandths of an inch, even though the software that comes with this, which is free, and it's also a free download, even though it shows the reading in magnetic force, it's a thousandth of an inch. It says 0.000, so it reads perfectly. And this is probably more accurate than my thickness calipers, because if you look at the ball underneath here, and hopefully I can show this, if I move that ball, you can see it wants to go back right to the center, and that is going to give you a very tiny area reading, a very small area of reading, probably a little bit smaller than my thickness calipers. So when you move this around, you can kind of get an average. Just look on the reading, look for the smallest area. So anyway, I'll show you here in a bit, maybe the next video, how to calibrate this.